Rationalizing denominators and simplifying quotients of radical expressions. To rationalize the denominator of a radical expression of the form a divided by the nth root of x to the n power, we multiply the expression by a fraction of the form the nth root of x to the k power divided by the nth root of x to the k power, so the radical in the denominator has a perfect nth power radicand. In these examples, we want to simplify. For part A, we have 8 divided by the square root of x. So we need to rationalize our denominator. Our first step is to figure out what we can multiply the square root of x by so I have a perfect square. Since x times x is x squared, if I multiply the square root of x times the square root of x, I'll have the square root of x squared. I need to multiply it by 1, so I have to multiply both top and bottom by the square root of x. This equals 8 square root of x divided by the square root of x squared. Final answer, 8 square root of x over x. The reason we multiplied the top and bottom by the square root of x was so that our denominator would just be x. So you can skip the middle step and go straight to our final answer. For part B, we have 3 divided by the square root of 5p. 5 is not a perfect square, but if I multiply the square root of 5 by the square root of 5, that would give me the square root of 25, which I can take the square root of. I have p to the first, so if I multiply it by another p to the first, I'll have the square root of p squared. Which means to rationalize my denominator, I need to multiply both top and bottom of this fraction by the square root of 5p. That equals 3 square root of 5p divided by the square root of 25p to the second, which equals 3 square root of 5p divided by 5p. Quotient property for radicals. If the nth root of a and the nth root of b are defined and b is non-zero, then the nth root of a divided by b equals the nth root of a divided by the nth root of b. In words, the nth root of a quotient is the quotient of the nth roots. For these examples, we want to simplify. For part A, I have the square root of 4 divided by x. Using our quotient property, I can rewrite this as the square root of 4 divided by the square root of x. I need to rationalize my denominator. If I multiply x times x, I would get x squared. So I want to multiply top and bottom by the square root of x. The square root of 4 is 2. The square root of x I bring over, divided by the square root of x times the square root of x is the square root of x squared, which gives me my final answer of 2 square root of x divided by x. For part B, I have the square root of x divided by 12y. So I can write this as the square root of x over the square root of 12y. Now there's two ways that I can deal with this denominator. 12 already has a perfect square because I can rewrite that as 4 times 3. So one method of working this problem is to simplify the denominator. So I have the square root of x divided by the square root of 4 is 2, square root of 3 I don't know, square root of y I don't know. Then I can rationalize my denominator. So I multiply this by the square root of 3y, because 3 times 3 is 9 and y times y is y squared. The 2 is no longer under the radical, so I don't have to include it. So multiplying this fraction, top and bottom, by the square root of 3y divided by the square root of 3y. That equals the square root of 3xy over 2 times the square root of 9y squared. This simplifies to the square root of 3xy over 2 times 3 times y. So my final answer is the square root of 3xy all over 6y. The other way I can work this problem is by multiplying top and bottom by our square root in the denominator, which would be 12y. So multiplying by the square root of 12y divided by the square root of 12y, on top I would have the square root of 12xy divided by the square root of 144y squared. I still have to simplify my 12 into 4 times 3. So the square root of 4 is 2. The square root of 3 we don't know. We don't know the square root of x or y. That's divided by 12y. Since 2 and 12 are no longer under the radical, I will have to reduce this. 2 goes into 2 one time and 2 goes into 12 6 times. Final answer would be the square root of 3xy divided by 6y, which was the same answer we got before. Your choices are to simplify your square root, then rationalize the denominator, or rationalize the denominator, then simplifying your root and reducing your fraction. For these examples, we want to simplify. Part A, I have the square root of 5b to the 5th divided by the square root of 7a, which means I want to multiply top and bottom by the square root of 7a to get my perfect square. This equals the square root of 35ab to the 5th over the square root of 49a squared. Simplifying what I can't take the square root of 35. I can't take the square root of a. But I can take the square root of part of b to the 5th. I can write b to the 5th as b to the 4th times b to the 1st. The square root of b to the 4th is b squared, and then I have a b under my root. And that's divided by 7a. So my final answer is b squared times the square root of 35ab divided by 7a. For part B, we have 2 divided by the cube root of 5. For this problem, to rationalize the denominator, I actually need 3 5s. So if I have 1 5, if I multiply this by the cube root of 25, I would have a perfect cube. So multiplying top and bottom by the cube root of 25, my result is 2 cube root of 25 divided by the cube root of 125. You could also just write this as the cube root of 5 cubed, which would be a little easier to simplify. My final answer is 2 cube root of 25 divided by 5. For these examples, I want to simplify. For part A, I have 4 divided by 5 times the cube root of x. In order to take the cube root, I would have to have at least x to the 3rd. 5 is on the outside, so I don't have to worry about that. So if I multiply the cube root of x by the cube root of x squared, I should end up with the cube root of x cubed. Multiplying top and bottom by the cube root of x squared, my result is 4 cube root of x squared divided by 5 cube root of x to the third, which gives me the final answer of 4 cube root of x squared divided by 5x. For part B, my problem is 6 divided by the cube root of 2x squared. I need 3 of the same thing in order to take the cube root. So to take the cube root of something with the base 2, I would have to have 2 times 2 times 2, which would be 8. 2 times 4 would give me 8. In order to take the cube root of something with a base of x, I would have to have x times x times x. I have x times x, so I need an x to the first. I want to multiply the top and bottom by the cube root of 4x. My numerator, I will have 6 cube root of 4x divided by the cube root of 2 times 4 is 8, x squared times x is x to the third. I can take the cube root of my denominator, 6 cube root of 4x divided by 2x. The 6 and the 2 are both outside the root and they're both even, so I can reduce. 6 divided by 2 is 3 and 2 divided by 2 is 1. The result is 3 cube root of 4x all over x. Using radical conjugates to rationalize denominators. The product of radical conjugates contain no radicals. If your expression is 4 minus the square root of x, then the conjugate will be 4 plus the square root of x, and our product will be 16 minus x. When you're dealing with an expression and its conjugate, the terms will be the same, but if the expression has a minus sign, then the conjugate must have a plus sign. If your expression is 7 plus 3 times the square root of x, its conjugate will be 7 minus 3 times the square root of x, and the product will be 49 minus 9x. If your expression is 2 square root of x minus 3 square root of 5, its conjugate will be 2 square root of x plus 3 square root of 5. The product is 4x minus 45. Rationalizing a denominator by using a radical conjugate. To rationalize the denominator of a square root expression if the denominator is a sum or difference involving radicals, 1. Determine the radical conjugate of the denominator. 2. Multiply the original fraction by the fraction conjugate divided by conjugate. 3. Find the product of the denominators by using parentheses a plus b times parentheses a minus b, which equals a squared minus b squared. In this example, simplify 1 divided by 5 plus the square root of 3. The conjugate of 5 plus the square root of 3 will be 5 minus the square root of 3. So multiply top and bottom by 5 minus the square root of 3. In the numerator, I'll distribute the 1. 1 times 5 is 5, and 1 times negative square root of 3 is negative square root of 3. Normally we'll shortcut to the result, but since it's the first one, I want to use the FOIL method to multiply this out. So I have 5 plus the square root of 3 times 5 minus the square root of 3. First, 5 times 5 gives me 25. Outside, 5 times minus the square root of 3 is minus 5 square root of 3. Inside, positive square root of 3 times 5 is positive 5 square root of 3. And last, positive square root of 3 times negative square root of 3 is negative square root of 9. This results in 5 minus the square root of 3 over 25. And then because we use the conjugate, negative 5 square root of 3 plus 5 square root of 3 is just 0, minus the square root of 9, which is 3. 5 minus the square root of 3 divided by 25 minus 3, which is 22. Just like when we used the quadratic formula, the only way this can reduce is if 5, -1, and 22 all had common factors. Since they don't, this is my final answer. In this example, simplify 2 divided by the square root of 3 plus the square root of 7. Our conjugate is going to be the square root of 3 minus the square root of 7. I want to multiply top and bottom by the square root of 3 minus the square root of 7. For my numerator, I'm going to distribute. 2 times the square root of 3 is 2 square root of 3, and 2 times negative square root of 7 is minus 2 square root of 7. That's divided by square root of 3 times the square root of 3 is the square root of 9. We know our inside and outside terms are going to cancel, which is why we chose the conjugate. And then positive square root of 7 times negative square root of 7 is negative square root of 49. Once you're more comfortable with this, you can go straight to this next step, which brings over 2 square root of 3 minus 2 square root of 7 all over the square root of 9 is 3 minus the square root of 49, which is 7. So that result is 2 square root of 3 minus 2 square root of 7 all over -4. This reduces because 2, -2, and -4 all have a common factor of 2. 2 goes into 2 one time, 2 goes into -2, -1 times, and 2 goes into -4, -2 times. One way I can write this answer is the square root of 3 minus the square root of 7 all over -2. Some books like to simplify this and have a positive 2 on bottom. All that does is changes the sign of everything. So my positive square root of 3 would be a negative square root of 3, my minus square root of 7 would be plus square root of 7, and my -2 would be a positive 2. Either answer is acceptable. In this example, simplify 3 square root of x divided by 4 square root of x minus the square root of 5. Again, we're trying to get rid of the square root, so we want to multiply by the conjugate of our denominator, which will be 4 square root of x plus the square root of 5. We need to multiply that by the numerator and the denominator. Distributing in the numerator, 3 square root of x times 4 square root of x is 12 square root of x squared, plus 3 square root of x times the square root of 5 is 3 square root of 5x, all over, for the denominator, 4 square root of x times 4 square root of x is 16 square root of x squared. Inside and outside cancel, so I have minus the square root of 5 times the square root of 5, which is the square root of 25. This simplifies to 12x plus 3 square root of 5x in my numerator, and in my denominator, 16x minus 5. Our final answer is in the numerator, 12x plus 3 square root of 5x divided by, in the denominator, 16x minus 5. Rationalizing denominators and simplifying quotients of radical expressions. To rationalize the denominator, if you have the square root, you want a perfect square. If you have a cube root, you want a perfect cube. If it's a fourth root, a perfect fourth root. Using radical conjugates to rationalize denominators, you want to multiply your numerator and denominator by the conjugate of your expression in the denominator, which means if your expression has a minus sign, the conjugate will have a plus sign. If your expression has a plus sign, then your conjugate will have a minus sign.